Okay, so we want to talk about rational functions, and we've seen these before. So I've got three functions set up here. These are all rational functions, and essentially what makes something a rational function, such as f of x here, it's that you have a variable in the denominator. You have a little polynomial in the denominator, and it can be in the numerator, but the key is it has to be in the denominator. So if you look at all three of these functions, 1 over x minus 2 and 1 over x plus 1 plus 2, and disregard this right here for a second or two. So we want to look at this. This comes out of your Hawks section, and I don't know if you can see this, but this right here is f of x, or 1 over x. So this one is 1 over x. And we've looked at that one before, and essentially there's this vertical little dotted line here. That's called a vertical asymptote. And then you've got this horizontal little dotted line, and that's called a horizontal asymptote. And essentially, you remember how the domain is all the inputs? Well, if it's inputs, then that's the x values. And the range, well, that's all the outputs. And if it's an output, then that's all the y values. Well, in this function right here, 1 over x, you cannot put an input of 0 here. X cannot be 0. If x equals 0, well, you're dividing by 0, and that can't happen. And look what happens here at x equals 0. Remember how if you graph x equals 0, that's a vertical line. We talked about that at the very beginning of the semester. So that's why you get this vertical asymptote here. So to find any vertical asymptote, you just set the bottom equal to 0, and it will tell you what it is. Now the horizontal asymptote is any of the outputs. If you look at the outputs of this, there is no way that you can get 0 out of this. If you put a 2 in, you get a half. If you put a 4 in, you get a fourth. If you put a 6 in, you get a sixth. The bigger the number for x, the smaller the fraction. So the bigger and bigger and bigger the x value gets, the smaller and smaller and smaller the y value gets. But you can never get 0 out of it. So that's why there's this horizontal asymptote at y equals 0. At y equals 0. Well, remember how we said about the transformations of functions? This is 1 over x minus 2. 1 over x minus 2. The minus 2 part, remember what that does? It shifts it to the right 2. And essentially, it just shifts the original vertical asymptote to the right 2 spots. The minus 2 is to the right 2. So it takes that and shifts it to the right 2. Or you just set the bottom equal to 0 and say x equals 2. That's the vertical asymptote. Okay. Now the horizontal asymptote didn't change any, right? We didn't shift anything up or down. There's nothing being shifted up or down. So the horizontal asymptote is still y equals 0. And we'll talk about that here in a second. The last function I have here is 1 over x plus 1 plus 2. Now remember the x plus 1, just like the minus 2 here, that's a horizontal shift. So it's going to go to the left 1. So that's why we're to the left 1 here. And remember what happens when you just add 2? It goes up 2. So your vertical asymptote is, well, it's x equals negative 1. And your horizontal asymptote, well, since I shifted it up 2, it's y equals 2. So just by knowing how you shift things around, you can find these asymptotes. But let's not look at it quite so much as graphing. Let's look at it just question by question. So I have a question here, and it says, given the following rational function, so let's take this guy here, negative 6 over x minus 2. If you want to find the vertical asymptote, the equation for the vertical asymptote, well, you're going to take the bottom and set that equal to 0, and it will tell you x equals 2. That's not too bad, right? That's how you find a vertical asymptote. So right now, let me see if I can draw this out. I've got a vertical asymptote at x equals 2. There's 1 and 2. And it's technically not part of the graph, but it's going to be like a boundary line. Your graph can't cross that, essentially. Your graph will never cross that line, because what happens is you can never put a 2 in. Once you put a 2 in, 2 minus 2 is 0, and you cannot divide by 0. So that's why there's this boundary line here. You cannot use x equals 2. The next step to the question is to find the horizontal or oblique asymptote. Okay. Horizontal I just talked about. Oblique, sometimes these dudes follow a asymptote that's kind of at an angle, basically. Okay, so essentially what you can do is, what Hawks tells you to do, is that to do your horizontal asymptote, you have to look at the degree of the top and the degree of the bottom. So for this scenario, this question, we'll take our function here and look at the degree of the top versus the degree of the bottom. Well, the degree of the top is 0. There's no x there, so the degree is 0. Now the x is here, the degree of that guy is 1. If the degree of the bottom is bigger than the degree of the top, so the degree of the bottom is bigger than the degree of the top, if that is true, then automatically every time your horizontal asymptote is y equals 0. Automatically. Because what's happened is you haven't shifted anything up or down, essentially. Okay, so that's one thing that you got to recall. Another one of those little tips. The degree of the bottom is bigger than the degree of the top, then you got y equals 0. Well, let's take a look at a different scenario. Let's take another function here. Well, what if it isn't bigger, right? What if you're looking at the horizontal asymptote, and let's say that the degree of the top is the same as the degree of the bottom. So they're both the same degrees. Well, if they have the same degree, which in this case is 1, and the degree of the bottom is 1, if those degrees are the same, what you do is you find it's a fraction, and it's the front coefficient of the top divided by the front coefficient of the bottom. Alright, so the front coefficient here is 1, and the bottom front coefficient is 1. So for this horizontal asymptote, you wind up with y equals 1 over 1, and 1 over 1 is just 1. So y equals 1. That's your horizontal asymptote. Vertical asymptote, remember I just said a second ago, a vertical asymptote, you just worry about the bottom. What number would give you a 0 in the bottom? A 10 would, right? So there is my vertical, and here is my horizontal. Not too shabby, right? So that's whenever the degrees are equal. Remember what happens when the degrees at the bottom is bigger than the top? It's automatically y equals 0. When the degrees are equal, it's a fraction. The front coefficient divided by the bottom coefficient. Well, let's see. I guess the other issue would be if the degree of the top is bigger than the bottom. So let me give you one that's like that. So let's get another function going here. 2x squared plus 10x plus 8 all over negative x minus 9. Well, let's worry about I don't know. Let's do the horizontal first. Horizontal asymptote. Remember, you're looking for the degrees. You're looking at the degrees. So the degree of the top here is 2 because of the power of 2. The degree of the bottom, well, there's nothing there but a 1, so it's a 1. So the degree of the top is actually bigger than the degree of the bottom. And when that happens, you don't have a horizontal, you have the oblique. You have the oblique asymptote, the one I talked about just a second ago, where it's going to be, the asymptote's going to be at an angle. And here's where you have to use that old long division. So we're going to divide this into that. Give me a different marker. You can see. So you're checking out this into that, right? You're checking out how do you make a negative x into a 2x squared? You multiply it by 2, a negative 2, x. Negative times negative is positive. 2 times 1 is 2. X times x is x squared. Now, negative 9 times a negative 2 is a positive 18, and x times 1 essentially times 9 is x. So it would be a positive 18x. Remember, you're subtracting here. So those cancel. 10 minus 18 is a negative 8x. And you just bring your 8 down. Positive 8 here. Just bring it down. How do you turn a negative x into a negative 8x? Looks like I just need to times it by 8. So I say plus 8. 8 times that's negative 8x. 8 times negative 9 is negative 72. And when you subtract here, that cancels. A plus B 80. And I'm not really worried about this remainder, because essentially what's going to happen is if the top is bigger, the degree of the top is bigger than the bottom, in this case it's bigger by 1, and that's when I have to do this. When the degree of the top is bigger than the bottom by 1, I should have said that at the beginning. When the degree of top is bigger than the bottom by 1. When the degrees are different by 1, you use your long division, it's an oblique. That's when it's oblique. Alright? So that's when it's oblique, when the degree of the top is bigger than the bottom by 1. We go through here, and when it's degree by 1, then essentially you're going to wind up with this linear answer here. You don't worry about your remainder. So your answer to this is this guy right here. This is the oblique asymptote. Y equals negative 2x plus 8. So there's your oblique. So we have an oblique asymptote. It's at an angle. Excuse me. Now we want to worry about our vertical asymptote. And remember, on vertical asymptotes, all you're going to do is just take the bottom and set it equal to 0 and see what value would give you a 0 on the bottom. So negative x minus 9 equals 0. You'd add 9. Negative x equals 9, which means a positive x equals negative 9. So x equals negative 9 is the vertical. And y equals negative 2x plus 8 is the oblique. Oops. The oblique asymptote. Okay, it leaves us one other scenario. What if your asymptote is not, say the degree of the top is bigger than the bottom, but more than just 1. So for instance, give you another function here. So the degree of the top here is 5. Zoom in a little bit. And the degree of the bottom is 1. When the degree of the top is greater than the degree of the bottom by more than 1, there is no horizontal / oblique asymptote. There is none. So none. There is no horizontal. Now you have a vertical. X plus 4 equals 0. So you subtract 4, x equals negative 4. You have a vertical. You have a vertical asymptote, but there is no horizontal. And I'll give you one more piece of advice, one more nugget of information. Say you had a function like this, and you're wanting to find the vertical asymptotes. Remember, for a vertical, you take the bottom and set it equal to 0. So I'm going to take the bottom, x plus 3, set that equals 0. X equals negative 3. You would think, well, that's the vertical asymptote. Well, if I take x minus 3 and plug this back in up here in the top, it will actually zero this top out. So for instance, negative 3 squared plus 4 times negative 3 plus 3. That's 9 minus 12 plus 3. 9 plus 3 is 12, minus 12, 0. If that occurs, there is no vertical asymptote. There isn't any. And I'll show you why. That top up here, that could be factored out, right? It could be x plus 1 times x plus 3. And the bottom is still x plus 3. Well, these are being multiplied together and is being divided by x plus 3. Well, they cancel, and essentially you're left with x plus 1. But you can't just forget about it because you started with a division. Now it simplifies to x plus 1, but you can't forget about it. So what happens is there is no vertical asymptote, but still you can't have x equals negative 3. So what you have is a hole. There's no vertical asymptote, but there's a hole there. And basically if you graph this, you'll have a hole in the graph. So sometimes there's no vertical asymptote and you just have a hole. You just say none. There's a hole at x equals negative 3. I'm not for sure. I don't think the homework will get into that. But it's out there in case there might be a bonus question or something. You never know.